Hello guys, and welcome to this video. In this video we are going to solve a problem in cinematics. It's a good question for all the people who love physics or working and studying Physics Olympiad. It's one of the questions of Iran Physics Olympiad at level 3. I will talk about Olympiad physics in Iran in detail in another video, but for now it's enough for you to know that level 3 is the level which students give medals there. It's not a very hard problem, but it's good to start. Actually, this question, it's good to start with this question. Without wasting time, let's read the problem. Okay, as you can see here, it says that from an inclined plane with angle theta, we shoot a ball with initial velocity v0 horizontally. Actually, this is the ball. Let me to draw the ball. I forgot to drop the ball. This is the ball, and it has a velocity v0 horizontally. And part A of the question is that what is the maximum length that the ball can achieve in the plane after the first collision? Means S0. I draw S0 in the picture. This is S0. And the part B of the question is that consider that the collision is elastic. I suppose that you know about elastic collision, about the conservation of energy and momentum. Because of this, I won't talk about that, or maybe I will talk about this in another video. What is the maximum length that the ball can achieve after the second collision? Means S1. This is S1 I draw in the picture. C is that if we double V0, what will the ratio S1 divided by S0 be? D is find Sn means the distance between the nth and the n plus 1th collision. I didn't draw them in the picture. Part D is that find Sn means I read this. Part E is that at the nth collision, what is the ball's place with respect to the origin? This is the origin actually. We drew in the picture. For large magnitude of n, what will the ratio Sn divided by Sn minus 1 be? Okay, let's solve the problem. Let's solve the problem. Part A is that what's the maximum length that the ball can achieve in the plane after the first collision? Means it wants us to calculate S0. We write actually cinematics equations. It's better to write the equations in the system of coordinates that is defined in the picture. Also, we can actually write the equations in this actual system of coordinates. It doesn't. Sorry about this line. And also write the equations in this system of coordinates. Actually, the answers don't change very much, but maybe it will be more complicated to solve the problem in this system of coordinates. It will be easier to solve this like this in this system of coordinates. Okay, let's write the equations. For the first, we should know about the acceleration to integrate from the acceleration to actually have the velocities, and again integrate from the velocities to achieve the places. For first, we write let me change the color to actually black. Okay, this is our inclined plane, and this is our coordinate system. This is y and this is x along the plane. The only force that the ball is affected by is the gravity force that it makes an acceleration g toward the ground. So here is g, and this g has an angle theta with the y-axis. So from this picture we can write that the ay means the acceleration in the direction of the y-axis is minus g times cosine theta, and the a of x means the acceleration in the x-axis is g times sine theta. Okay, and you can see that they are constants, so we can integrate them very easily. If we integrate them, If we integrate them, we will find the Vy, it is function of t, and also Vx, it is also the function of t. It will be minus gt cosine theta plus, and also we have initial velocity in the y direction that it is, you can see here, it is also theta. It is v0 actually sine theta. So we write here plus v0 sine theta, and vx of t is minus plus g t sine theta plus v0 cosine theta. Again, we integrate from these formulas to obtain actually the x of t and y of t, x of t and y of t. The x of t will be g t square divided by 2 sine theta plus v0 t cosine theta, and y is also cosine theta plus v0 t sine theta. Okay. Actually, they have x0 and y0, but x0 and y0 are equal to 0 because we take the coordinate of systems at the origin, and we shot the ball from the origin that it is on the coordinate of it is on our coordinate systems of coordinates, and so x0 and y0 are equals to 0. So okay, but how should we understand what is S0? Actually, you can see here that in the first collision, it is the first collision here, that the ball, the y value, the y magnitude of ball is 0. It is 0 in two places. In the first place is that when you are shooting the ball, that it's in the origin, and the y and x is 0 are 0. And another place is here in the first collision that again x is not 0, but again y is 0. So we should obtain the time, we should obtain the t, I called it capital T, that the y of t is going again to be 0. So I will say that y of y in the t is going to be 0, that t is not 0 because t can be 0, but we want that time that t is not 0. So y capital T is 0, and here x of that t is going to be S0. So we should find the t, we should find the capital T in this equation, and actually substitute it in this equation to actually obtain S0. Okay, let me write this. It is minus g t squared divided by 2 cosine theta. It is actually, if I write this equation, it will be like something like this: v0 t sine theta. If I calculate capital T from this equation, it is going to be 2 times v0 divided by g, 2 v0 divided by g, actually tangent theta. This will be t, and I can now calculate S0. S0 is x of capital T, and this is v0 cosine theta, 2 v0 divided by g. I write tangent theta here as sine theta divided by cosine theta to eliminate these cosine theta from the denominator and numerator. And like this, something like this, plus g sine theta divided by 2 capital T square, and it is 4 v0 square divided by g square sine square divided by cosine square. Okay, I should do some algebraic calculation with this to actually simplify the answer. I can factor the term 2v0 square divided by g from the terms, and here we have some trigonometric formulas, trigonometric expressions, that is sine theta, sine of theta plus okay, here I can eliminate this with this and also this with this, 2v0 square divided by g, and here we have sine to power 3 divided by cosine power 2. Again, I can actually simplify this. I can write this as something like I can make a common denominator plus sine to power 3 divided by cosine power 2. Here I can write actually cosine theta to power 2 as 1 minus sine power 2 of theta, sine square of theta, and I can obtain from this sine theta divided by cosine square, and it is something like this. Cosine theta tangent of, this is part actually A. This is actually A S0. Okay, let's to solve part B. It said that consider that the collision is elastic. What is the maximum length that ball can achieve after the second collision? Means it wants us to calculate actually S1, and S1 is the distance from the first collision and the second collision here. We can solve this as we can actually change our systems of coordinates and put it on the place of that we have the first collision, something like this. Let me to write it for you. This is the inclined plane, and here, for example, we had a ball that we shot it. Here is the first collision. We can actually take our systems of coordinates here. It is y again, and it is x here, and again after the first collision the ball goes and again it hits the inclined plane here. For the calculation, for example, I take the time actually t equals 0 here. So I should calculate v of x here, vx here, and also vy here, and just that, because the acceleration is again constant and it's equals to g and it's downward. So we should just obtain vy and vx after the first collision to actually obtain the S1 that the question wants. Okay, let's calculate v of x. What is v of x? Can you say what is v of x here? Let me call it v prime of x for actually avoid of confusion. And okay, what is v prime of x? Can you say that what's v prime of x? V prime of x is nothing, just v of x at the time v of x that we obtained above. This is v of x. Let me call it, yeah, this is v of x. This is v of x. V prime of x is just vx at time capital T. So we should write that g, what was that? G sine theta times capital T, g sine theta, g sine theta, capital T was 2 capital T was this, 2v0 divided by g sine theta tangent theta sine theta divided by cosine theta plus v0 cosine theta, and that is, we can eliminate them, and we can also factor the v0. It is 2 sine square of theta divided by cosine of theta plus cosine of theta square cosine of theta divided by cosine theta. I just make a common denominator, and we know that sine square plus cosine square is 1. So v prime of x is v0 1 plus sine square of theta divided by cosine. This is v prime of x. It means that it is the initial velocity after the first collision. Let me to draw a rectangular around it, or a cloud around it. A cloud is better. And also let us to calculate v prime of y. What is v prime of y? Can you say that? What is v prime of y? Actually, v prime of y is actually here, if you calculate v of t at the time here, v of t at the time capital T, you will obtain the velocity, you will obtain minus 1 times v prime of t. Why? Because the collision is elastic, and after the first collision, the magnitude of velocity in the direction of y-axis doesn't change, but the thing that changes is just actually direction. Is the direction. It means that the direction is downward when you are hitting, the first time you are hitting the inclined plane, and after that the direction of the velocity in the direction of y changes. You can see here that here is ball, and it goes and hits the inclined plane, and the velocity of v of y is downward. But after the collision, because the collision is elastic, we just actually change the direction of vy, and the magnitude doesn't change. So v prime of y, let me write here, v prime of x was vx in the time capital T. Let me to change the weight of the v prime of y is minus vy at the time capital T. And what is that? It was to copy this, paste it here. Okay, but this is capital. Okay, it is v0 sine theta minus g cosine theta times capital T was 2v0 divided by g sine theta divided by cosine theta. We can eliminate this and this with this. So it's minus 1. Sorry, it's minus 1. Should multiply this with minus 1. With minus 1, and you can see that it is minus v0 times sine theta, so it equals to v0 sine theta, and it is also the v prime of y. The cloud around it. So now we have the initial velocities for our second part of movement of the ball. So we can again write the equations in the new system of coordinates, and to obtain the S1. Okay, again, our acceleration in the y direction is minus g cosine theta, and a of x is g sine theta. Again, we can integrate from these equations, and we have actually initial velocities in the second part of movement. So the v of y of function of t, but you should be careful that our t is 0 after the first collision. It is not equal as that t that we solved the first part of the equation. You can see here that t0, I changed the time. I changed the time t that it is 0 after the first collision. Okay, so the vy of t is, should integrate from this, so minus gt cosine theta plus v prime y, that is the initial velocity in the second part of the movement. So it is v0 times sine theta, and also vx of t, that it is gt sine theta plus v prime of x. V prime of x is v0 1 plus sine square divided by cosine theta. Okay. So again, how can we obtain S1 from these equations? Again, you can see that in here. Oh, I forgot to write actually the places. We again integrate from these equations and obtain y of t minus gt squared divided by 2 cosine theta plus v0 t, and also x of t okay. But how can we obtain, and again y0 and x0 are 0 because we change our coordinates and we put it at the place where we have the first collision, means here. So how can we obtain again S1 from these equations? Again, you can see that in two places our y is going to be 0. First at here, let me to draw a circle around them with another color, here and here. Our y of t, let me call this t, again capital T, is going to be 0, and actually here again y of 0 is going to be 0. So we should actually do this equation that y, let me change the color, y at time capital T is 0 and x of time capital T is equal to S1. So if I solve this equation, the t is again 2v0 divided by g tangent theta, and so S1, that is x of t, is going to be g sine theta divided by 2 capital T square, that is 4v0 square divided by g square sine square of theta divided by cosine square plus v0 1 plus this expression and this. Again, we should make some simplification on this. I can factor the first, let me to eliminate the common terms. We can factor the term 2v0 squared divided by g. Have just trigonometric expressions in here. It is sine to power 3 cosine square plus actually sine theta plus sine to power 3 of theta divided by cosine square of theta So I can write it as, I can again factor sine theta and cosine square of theta. It is 2v0 square sine theta divided by g cosine square of theta. And here we have just 1 plus 2 sine square of theta. And this is just S1. This is B. Let's go to the part C. Part C says that if we double V0, what will the ratio S1 divided by S0 be? Actually, what is S0? You can see that S0 is here, 2V0 square tangent theta divided by g cosine theta, and also S1 in here. And if you just actually pay attention to the note, is that S1 is actually S0 times 1 plus 2 sine square, as you can see from the part A and B. So S1 divided by S0 is just 1 plus 2 sine square of theta, and it is not a function of V0. It is not a function of V0. It means that if we change V0, our ratio doesn't change. So we say that it doesn't change. This is also part C. Okay, that was so easy. Let's go to the part D. Part D says that find Sn, means the distance between the nth and n plus 1th collision. Again, for doing this, we should actually obtain the v of x and v of y after the nth collision. If you paid attention, you understood that if we wanted to find the S1, we actually found the v of x after the first collision and v of y after the first collision. So if you want to find the distance, I mean, if you want to find Sn, you should actually understand the v of x after the nth collision and v of y after the nth collision. But how should we do this? If you paid attention again, you would notice that our v of y doesn't change. If you can see here, our v of y before the first collision, in the shutting process, was actually v0 sine theta, and after the first collision, we find v prime y here. What was v prime y? What v prime y was again v0 sine theta. It means that our v of y after the collisions doesn't change. So after the nth collision, let me right here. Let me draw the picture. The first collision, the second collision, and so on. It's the first, it's the nth collision. Our v of y doesn't change. So here we have, after the nth collision, we have v0 sine theta of velocity. And also, if you paid attention, you would notice that the time of the movement in each part doesn't change. It means that here the time that the ball was in the air was t, capital T. That was 2v0 divided by g tangent of theta. Here again was t, because the equation in the y direction doesn't change, because the velocity didn't change, so the time won't change. So here it's t, and also here time is t, the time of that the particle is in the air. So the only challenge is to find the v of x here. What is the v of x here after the nth collision? I call it vx of n. Here is vx of 0, vx of 0. Here it means we didn't have any collision before that. Vx of 1, vx of 2, and vx of n. Our challenge is to actually calculate the vx of 1, and I mean that we must find a sequence of vx of n's to find from that sequence we should find an algorithm, we should find some relation between vx's to find the vx of n. So let me to write the vx of 0 and vx of 1, vx of 2, and others to find actually the relation. For the first vx of 0, what was that? It was just v0 cosine theta. That was v0 and it was theta. What was vx of 1? It was vx of t, capital T. That, what was that? It was, I think, was that, I forgot. It was v prime of x, v prime of x, v prime of x, sorry about the pronunciation, v prime of x, that was v0 times 1 plus sine square divided by cosine theta. Let me write it, v0 1 plus sine square of theta divided by cosine theta. Okay, let's find actually vx of 2. We understood that the time of the direction, the time of the duration of our movement in the air doesn't change actually after the collisions. So I can calculate it from the actually equations of movements. How can I do this? I can actually change my coordinate system into here, like the previous parts. Actually, coordinate system here, systems of coordinates here, and again write the actually and consider that t0 is here, t0 is here, and again find the velocity of time, the function of velocity of time, to calculate vx in here, because I know that the time which the ball hits the inclined plane is t, capital T. So I write a of x, the acceleration in the x axis doesn't change, g, and what was that, g sine theta, integrate from this, v of x time t, function of t is g t sine theta plus vx of 1. Yes, yes, because we are here, t0, we are here, and we are here, and here our initial velocity is vx of 1, vx of 1. So we will have dt sine theta plus vx1, just that. So, and I know that vx of 2 is just vx at time capital T. So it is g sine theta to v0, it is capital T tangent theta. Let me to write this as sine theta divided by cosine theta plus vx of 1. Vx of 1 was v0 here, vx of 1 was here, it is v0, 1 plus sine square divided by cosine theta. And we should simplify that. Vx of 2, so Vx of 2 is eliminate g and factoring v0 from the both terms. It is 2 sine square divided by cosine of theta plus 1 plus sine square plus cosine divided by cosine theta. It is v0 1 plus 3 times of sine square of theta divided by cosine of theta. Okay, I think that we understood the relation here, but for actually we can do another. We can also find Vx of 3 to actually find out that our relation, that the relation we found is correct or not. Vx of 3 is also gt sine theta plus Vx of 2, and gt sine theta, it's just v0 is just v0. Let me to write this v0 here, sorry, it is g sine theta to v0 divided by g sine theta divided by cosine of theta plus Vx of 2, and that is v0 1 plus 3 times of sine square divided by cosine of theta. And if you simplify that, you will understand that it will be v0 1 plus 5 times sine square of theta divided by cosine of theta. So we found the relation. It means that after the first collision, our Vx of n is v0 v0 is just actually v0 1 plus, after the first collision, plus, let me see that, here, 1 plus sine 2 or sine square divided by cosine of theta. After the second collision, v0 1 plus 3 times. After the third collision, 1 plus 3 sine square of theta divided by cosine of theta. So after the nth collision, you can understand, you can obtain that it is going to be v0 1 plus 2n minus 1 sine square divided by cosine of theta. You can see that if we substitute n by, for example, 2, we obtain here 2 multiplied by 2, it's 4 minus 1 is 3. It's obviously this, and it's true. Okay, so we found actually, let me to draw a picture again. Here is here, and here is the nth collision, and here we have another collision, n plus 1. Here we have Vx of n, and again v of y, v0 times sine theta, and the time t is the time of the duration that the ball is in the air. So we can calculate this distance, which we call it Sn. So Sn is just xn of capital T. It is what is this? I need to write the equation. What was the a of x? It was g sine theta. So the v of x was vn was actually gt sine theta plus vxn. Here vxn, this is this, and so the xn of t is going to be gt square divided by 2 sine theta plus vxn times t. So if we substitute capital T in this equation, we will have Sn is equal to xn of t. I need to erase this. It's just g sine theta divided by 2 or v0 square g2 sine square divided by its capital T square. And it's vx of n sine square, I think, cosine theta. Let me to see that it's correct or not. Okay, it's correct. And capital T2 v0 divided by g sine theta divided by sine theta. Again, I can do these algebraic calculations and say that xn of t, that is Sn, is factoring the 2 v0 square, divided by g. And here we have sine, actually sine to power 3 divided by cosine square of theta plus, and here we have sine of theta plus 2n minus 1 sine to power 3 of theta divided by cosine square of theta. Okay, so if we simplify this, Sn is going to be something like 2v0 square divided by g, and here we have cosine of theta, sine square of theta, and actually here I can factor the term sine theta from the denominator, and here we have 1 plus actually 2n sine power sine square of theta, I think. Yes, and actually I can say that it is this tangent theta divided by cosine of 1 plus 2n. Okay, this is actually S of n. This is part, what was that part? Part D. Okay, let's go to the next part. Actually part E, the last part. It says that at the nth collision, what is the ball's place with respect to the origin? Means it wants us to calculate actually, for example, if we put here 1, it means that at the first collision, what is the ball's place with respect? It's S0. Let us to replace this n with 2 at the second collision. What is the ball's place with respect to the origin? Actually, it is just S0 plus S1 here from this distance here from here. S0 plus S1. So the second was S0 plus S1. The third is S0 plus S1 plus S2. The fourth one is S0 plus S1 plus S2 plus S3. And so the nth one is actually, sorry. The nth one is just actually, what was the color? This should be color. The what I call it L, for example, L of n after O. L of n is going to be sigma s j's from j1 to n minus 1. It means that s1, s0, sorry, s0, j of 0, s0 plus s1 plus s2 plus s n minus 1. Okay, we should calculate this. Let me to write these first terms to obtain actually again the relation. Actually, I can actually factor this term to this term 2 v0 square time divided by g tangent theta divided by cosine theta from all of these si's and just some of the trigonometric part in here. So we can say that it equals to 2v0 square, what was that, divided by g tangent theta divided by cosine of theta. The s0, let us to substitute here, and with 0 it's 1, just 1. For the s1 is just 1 plus 2 sine 1 plus 2 sine actually square. For the let me do 0 s1 s2 is just 1 plus 4 sine square, and for the n minus 1 is just 1 plus 2n minus 20. It is 2 times n minus 1. It is 2 times n minus 1. Yes, sine square. So here we have n minus 1 actually terms, so we have n minus 1 ones here, 1 1 1, and there are n minus 1. So we have this term, it equals to, let me call it alpha n minus 1 times 1, that is n minus 1, plus I can actually factor 2 sine square of theta, and here we will have again 1, here we have 2, again we have 3, plus until we have, I factor 2 and plus n minus 1, and this is just n minus 1 divided by 2. I suppose that you know how to calculate this. Yes, so we will just have alpha n minus 1 plus this, we can eliminate this 2 with this 2, n minus 1 sine square of theta, so it is just alpha n minus 1 times 1 plus n sine square of theta. And let me to substitute alpha here. It is just 2v0 square divided by g tangent of theta divided by cosine of theta. Let me take that, yes, and times n minus 1 times n plus n sine square of theta. And this is part, actually this is ln, I called it ln. Actually this is part E of the question, and just a little question following part E. It says that, go up, for large magnitude of n, what will the ratio Sn divided by Sn minus 1 be? It means that we should limit when n is going to infinity. So we calculated Sn. What was Sn? Sn was this was Sn. So if we divide actually Sn by Sn minus 1, this alpha, that we take it alpha, will actually eliminate with both sides. Actually with we can eliminate this from denominator and denominator, and the only term that we will have is something like this: Sn divided by Sn minus 1 is going to be 1 plus 2n sine square divided by 1 plus 2n minus 1 sine square. And if we want to calculate the limit of this term when n is going to infinite, it will be, we can actually do this. We can divide both terms by n. It is 1 divided by n plus 2 sine square of theta, 1 divided by n plus 2, 1 minus 1 divided by n sine square of theta, and so 1 divided by n is going to be 0 when n is going to infinite, so we can eliminate this term, and we will have 2 sine square of theta divided by 2 sine square of theta, which is just 1, and it is also the part E. Okay, we finished this actually a problem. I will appreciate you if you comment below, and if you like, you can subscribe our channel for more problems. I will put more problems if I have time, and just that. Thank you.